Hello everyone, welcome to my first ever tutorial. In this video, I will show you how to implement a 2D SoftBody character using Unity. The reason I'm making this video is because working on my current project, I have found that unlike for 3D, there isn't much talk about how to implement that concept in 2D. So if you're looking for an easy way to do it, I hope this video will be helpful to you. But before we start, this is a new channel, so I would appreciate if you support it by liking and subscribing. And you might as well ring that bell button since I don't upload that frequently. If you have any questions, don't hesitate to ask me in the comments below. At first, I had no idea how to approach this, so I started googling stuff. Then I found that one video from Binary Lunar that does a great job explaining the core mechanics behind it. I'll leave a link in the description and I encourage you to check out their channel. Their approach was to have multiple rigid bodies connected to each other using different types of joints. These joints make them have a certain behavior as forces are applied to them. We will have distance joints connecting each point to the point next to it, forming this circle of distance joints. And each point will also have 3 spring joints, one connected to the center point and each of the other 2 connected to a neighbor point. So what we'll do here is use this concept and apply it to a sprite shape that will deform according to the position of these points. Let's quickly go through the process of creating the main structure. Notice that all the points around the center point are its transformed children in the hierarchy panel. Once we achieve a satisfying behavior, we can create the sprite shape that will represent the soft body material of our character. This sprite shape must have a number of vertices equal to the number of rigid body points around the center point. As we will later on add a script to dynamically position each sprite shape vertex in the right location according to those points. So it doesn't really matter where you position these points initially, since we're gonna move them using this script anyway. What's important is that we have the same number of vertices as the number of rigid body points around the center point, which in this case is 6 points. The sprite shape is also a transformed child of the center point. To make this sprite shape look decent, I'm gonna give it an example texture. I have this sprite shape profile ready for this. If you don't know how sprite shapes work, check out Unity's learning platform. They have very clear tutorials about it. I'm gonna rename the sprite shape to something better and try to run the project. As you can see, the sprite shape is following its parent transform, which is the center point. But none of the sprite shape vertices are moving. Pretty bad. Let's go ahead and fix it right away. Create a new C# script and name it SoftBody. This script will take control of the sprite shape's vertices and put them in the right positions. Delete everything inside and split your code to 3 regions. One region for the fields, one for mono-behavior callbacks, which are the methods called by the game engine, and one for the private methods. In the fields region, create two serialized fields, one of type sprite_shape_controller and a transform array to store our rigid body points positions. In the monobehavior callbacks region, override both the awake and the update methods, or just the update method, and call the method update vertices, which doesn't exist yet. Create that method in the private methods region. What we will do inside is loop through each rigid body point, get its position, and assign it to the according sprite shape vertex. But we can't give it the exact location of the point. Since the collider is a circle, we have to offset it by the radius of that collider. If two vertices become too close, we might get an illegal argument exception. So it might be a good idea to handle that exception by relocating the faulty vertex in the catch block. Save the script, go back to Unity, and assign the script to the center point object. Assign the points to the transform array field and make sure the last one in the array is the center point. Assign the sprite shape to the sprite shape controller field as well. If you run the game now, you will immediately notice something really weird going on. As you can see, the vertices are following the points correctly, but they aren't rotating with them, which causes these twists in the outer edge of the sprite shape, which is really bad. We need to reorient the tangents so that they are always pointing the right way. A possible way to do it is to calculate the rotation of each point and rotate the tangents as much as that point rotated. But the tangents are vectors, and rotating vectors isn't straightforward. I tried to find a simpler way to do it, and if you analyze the target behavior of the tangents, you can see they almost always are perpendicular to the vector originating from the vertex in question towards the center point. So we will use the static method vector2.perpendicular to find the vector perpendicular to the towards center vector, give it the initial magnitude of the tangent, and assign it to the right tangent. The left tangent is just the negative of the first one. And finally, run the project and watch your satisfying SoftBody character bouncing around. I hope this video was helpful to you. If it was, leave a comment, like the video, and subscribe to my channel. Bye!